Hi, I'm Garrett Sparks, and this is the pancake sorting algorithm. After you pour your pancake batter into your pan, you cook your pancake until it bubbles. You then slide your spatula underneath your pancake and lift it up, turning the pancake completely over. Now you have flipped your pancake. So let's talk about the pancake problem. Now that you know how to flip a pancake, imagine a stack of pancakes with a unique size. You want the largest pancake on the bottom of your pan and the smallest at the top, like a pyramid. We want to sort the pancakes with the fewest reversals as possible. So how do we do this? If the largest pancake is in the middle of the stack, we will flip that pancake and all the other ones above it over. This brings the largest pancake to the very top and flips the whole stack over, bringing the largest to the bottom. We will repeat this until they are completely sorted in order. So here's an example. Pancake 4 is our largest. It is somewhere in the middle of our stack. To get to the bottom of our stack, we will flip 4 and all the pancakes above it over. This brings 4 to the top, and we see 2 is now beneath it. We flip the entire stack over, bringing 4 to the bottom, and now 4 is in the correct place. Here's our stack of pancakes. We want 1 at the top and 4 at the bottom. To do this, we must bring 4 to the top first and flip everything above 4, like this. Now, we want 4 at the bottom. We can flip 4 and everything below it over. Now, 4 is at the bottom. Next, we want 3 in the position right above 4. To do this, we will flip 3 to the top, which it already is, and we will flip everything from 3 to the position we want it at. Now 3 is in this position we want. Next, we want the order to go from 1, 2, 3, 4. So we will bring 2 to the top. It already is there. And we will flip 1 and 2. Now we have the correct order and it requires no more flipping, and our algorithm is complete. So let's begin with our Python implementation. We define flip, and this reverses the first k elements of the array. Now let's define pancake sort. You get the length of the array. You iterate from one end of the array to the beginning. We find the index of the maximum element. And if the maximum element is not in the beginning, we flip it to the correct position. We then return the sorted array. There are other implementations of this which involve finding the maximum value in another function, but for efficiency, I've implemented the Python slicing operator below. Here's some examples. We have an original array, which is our input, and this is the sort. You also can randomly generate an array. Here's our randomly generated array in the bottom, and the sorted following it. There's also a recursive approach, which calls on itself to handle smaller subarrays that were created. This is opposing the for loop that was shown previously. As for our time complexity, the flip function takes O of k elements. The pancake sort function iterates from n down to 2, where n is the length of our array, and this is an n minus 1 iteration. We also have to find the maximum size of our array, which takes O of size time, and then the flip, which is the max index plus 1 time, and then the following flips will take O of size. This gives us time complexity shown below, and we simplify this down to O of n squared. Let's compare this to other algorithms. The goal is to minimize the number of flips. Pancake sorting aims to affect an entire subarray in a single move as opposed to dividing the array and comparing elements. The time complexity is O n squared, while merge sort and quicksort take O n log n. Pancake sorting is not the most efficient method, so why do we use it? It has some very specific niche scenarios like robotics programming, machine conveyor programming, in game development. It is more of a theoretical and educational application, and something interesting to learn. It's not the most efficient. You probably wouldn't use it in the real world. Thank you so much.